Hello, this is Rob, and this is Statistics, Math 150, Chapter 10, Section 10.2, Correlation and Regression. So before we start off, we just want to ask a simple question. What are you looking forward to most about winter break? I know for me it'll be Christmas. So I'm going to go over some common terminology. So we have the regression line, which is the line of best fit of the data. This is used to see a trend and make predictions based on that data. Next we have the residual, and that's the predicted error. And this is the difference between the actual value of y and the predicted value of y primed for a specific value of x. Next we have marginal change, which is the magnitude of the change in the dependent variable when the independent variable changes 1 unit. Next up we have extrapolation, and this uses the equation for the regression line to predict y prime for a value of x that is beyond the range of the data values of x, and this is used to make predictions beyond the bounds of the data. Influential observations or influential points is an observation that when removed from the data values would greatly change the position of the regression line. Next up we got regression itself. And then regression, as mentioned in 10.1, in order to determine a relationship between two variables, we must collect data, construct a scatter plot, determine the linear relationship, whether that be positive, negative, curvilinear, or non-discernible, compute the value of the correlation coefficient, and then test the significance of the relationship. If it is significant, we now determine the equation for the regression line. Next up, we got the line of best fit. The line of best fit. So the best fit is the sum of the squares of the vertical distance from each point to the line that is at a minimum. In the figure below, there are multiple lines of best fit due to the variability of the data. The residual is the difference between the observed value and the predicted value. It is used to determine which line of best fit to choose, whether that be between the multiple lines in the previous slide. Whichever line has residuals of the smallest value, that is the distance between the points, and the line is the smallest, is the line of the best fit. Method of least squares. That is the method used for making the residuals as small as possible. Using this method creates the least squares regression line. We use a line of best fit in order to predict the values of y from the values of x. The better the fit, which would be the closer the points are to the line, the better the prediction will be. R is the name of the regression line, and that line can have a positive or a negative slope. Determination of the regression line equation. The usual equation for a line is y equals mx plus b. In statistics, it will be y primed equals a plus bx. A is the y primed intercept, and b is the slope.
Now, the two formulas for finding the equation of the regression line are, for a, you have the sum of y times the sum of x squared minus the sum of x minus the sum of xy over n times the sum of x squared minus the sum of x squared. And for the b variable, you have n times the sum of xy minus the sum of x minus the sum of y over n times the sum of x squared minus the sum of x squared. Moving on, we have the rounding rule for the intercept and slope. So we have to round the values of a and b to 3 decimal places. So in order to find the regression line equation, we first have to make a table, and then we have to find the values of x squared and y squared and put them in their appropriate places in the column. And if r is significant, we substitute in the formulas to find the values of a and b for the regression line equation. When drawing the regression line, truncating the graph may be needed, and this is completed when the distance between the origin and the first labeled coordinate on the x-axis is different from the distance between the rest of the labeled x-coordinates, or if the distance between the origin and first labeled y' coordinate is different from the distance between the other labeled y' coordinates. When graphing the regression line, select x values between the smallest x data value and the largest x data values. If r is positive, then so is b, and if r is negative, b is also negative. And you should use these guidelines when making predictions. The points of the scatter plot fit the linear regression line reasonably well, the value of r is significant. The value of a specific x is not much beyond the observed x values in the original data. If r is not significant, then the best predicted value for a specific x value is the mean of the y value in the original data. The value of the slope b is the marginal change. Extrapolation must be interpreted cautiously. Predictions based on present conditions may not continue in the future. Scatterplots must be checked for outliers, which is a point that seems out of place compared to the others. These points can affect the equation of the regression line. When this occurs, they are influential points or influential observations. Outliers may be influential points that draw the regression line toward itself. To test this, graph one line with the point and one without the point. If the line without the point is considerably different from the first line, it is influential. Outliers in the x direction tend to be influential. For some examples, we have, given this data table, we're asked to find the equation of the regression line of the data. So we simply have to find these variables n, the sum of x, the sum of y, the sum of xy, and the sum of x squared, and we plug these into the equation, and we find out that the regression line is y prime equals 0.396 plus 0.106x. And for example 2, we have a similar situation where we just have to add the number of absences, which is our sum of x. Our n is 7. The sum of y is the sum of all the final grades. The sum of xy is found by multiplying the number of absences by the number of final grades and then adding all of those up together. And then the sum of x squared is just the number of absences squared. So if we plug that into the equation, we get y prime equals 102.493 minus 3.622x. For the third example, we are given a situation where we need to predict the final grade for a student who missed 4 classes, which means that our x equals 4, and we simply put that into the equation. And after doing so, we find that the student's grade in the final exam is predicted to be about 88. Moving on to the application to a real-life situation, we can apply this to economics, where we, on a graph, put down the GDPs for different years, and based on that, on those data points, we can create a regression line, and from that we can use that to make predictions about the future of the United States GDP. And in application to the video, we can use a table of the pH level and the amount germinated, and use the pH level as the x and the germinated as the y, and find the same variables we need, the x, the sum of x, the sum of y, sum of xy, sum of x squared, and the n, and put this into a regression line equation. And this can also be used to predict the future experiments of the quantity of beans germinated based on each pH level. Thank you. This has been our presentation. Thank you for listening.